Okay, so for this one, we look for the one carbon that's different. It's the first step. So we can see here this carbon has two hydrogens. This carbon has two hydrogens. This carbon has a methyl and a methyl. This one has a hydrogen attached, a methyl, propyl, and this is, I think, isopropyl. So we look for the one that doesn't have any duplicates, which would be this one. The hydrogen in the back, since it's the lowest priority, we want to leave it in the back. If the molecule was like this would be in the front, so you would want to move it and turn it around. I'm going to fit that. So now, once we get that situated, we go and look for which molecules have the highest priority. One bond out, they all have carbon, so we have to go another bond. This is all three hydrogens, so this is going to be the one second lowest priority. We can now compare these two. So we go another bond out, carbon, two hydrogens. This would be two carbons and one hydrogen. So two carbons and one hydrogen is higher priority than two hydrogens and one carbon. So we proceed with naming it. 1, 2, 3, 4, 5, 6. That would be hexane. There's a methyl on the second and methyl on the third. So we put dimethyl. 2, 3, dash. And we figured out the priorities. This had the highest priority because it had two carbons and one hydrogen. So this would go this way to this one that only had one carbon and two hydrogens, and then down to the methyl. So clockwise would be R. And let's see if that's right. Okay. Next. Okay, we draw the heptane first, which is 7. Oops. 1, 2, 3, 4, 5, 6. At the 2 position, we've got a methyl. At the 5 position, we've got a methyl. Add our hydrogens, arrange, fit, roll. Now we look for the one carbon that's different. So as we can see, this carbon has two hydrogens, this carbon has two hydrogens, this one as well, this one has a methyl. So the one that would be different would be this one. And we see the hydrogen poking out front. We gotta turn it around so it's in the back. And again, most of the time, the methyl down here is gonna be the second to least priority, so we can basically just ignore this one and just focus on these two. So now we can go out and find the highest priority. So we go 1, 2, since carbon is the same. So you have one carbon here, two hydrogens. So we go out one more. So this would only be 3 hydrogens. This one would be one carbon, 2 hydrogens. So this would be the highest priority, second, and the least. So this would be S. We have to change this to a mirror. So now we have the highest priority on this side, the second lowest, and the lowest. Let's see if that's right. Okay, again, we look for the one that doesn't have any duplicates. I mostly look for the ones that have a hydrogen by itself, because these you can count out, these you can count out. This one has 2 methyls attached, so it would be this one right here, a methyl and everything else attached. Hydrogen's in the front, so we turn it around. And I always like it with a methyl on the bottom. It just helps me visualize, but some people have it on the top, so if you want to do that, either way, if you have it on the top or the bottom, you still get the same outcome. So again, I usually ignore this one and I start counting for these. So we go 1 methyl out, 2 hydrogens. We go another methyl out, a carbon out, 1 carbon, 2 hydrogens. 1 carbon, 2 hydrogens. So that would be the same, you keep going out. And most of the time what I've noticed is that when you have a long branch like this and you have a carbon attached to 2 other carbons, most of the time it works out that this is the highest priority, but I always like to double check to make sure. So as you can see, we had to go another one out. It'd be 3 hydrogens against 2 carbons, 1 hydrogen. So for sure this is the first priority, this is the second, and this is the third. So then we would name that 1, 2, 3, 4, 5, 6 hexane. We've got a methyl 2 position and a methyl on the 4th position. So 2, 4 dimethyl. This was the highest priority, this was the second and third, so it's in clockwise. So we put R dash. Let's see if it's right. Okay, we do the same thing. We're looking for the one that's different. I already see the 2 hydrogens right here. I see the 3 methyls right here. So this is going to be the one that's different. Or sorry, I should say the correct term is the chiral center. So you put the hydrogen in the back. I'm trying to turn it in a way. Okay, I like mine on the bottom, so I try to turn it that way. And now I ignore this one. I compare these two. So I already see branching, so I'm assuming that this is going to be the highest priority, but let's double check. So we had gone out for these, carbon was the same, so now we go another one. 1 carbon, 2 hydrogens. We go out 2 carbons, no hydrogens, but it's still higher than just 1 and 2 hydrogens. So what we would name this would be 1, 2, 3, 4, 5. That would be pentane. And there's 2 methyls right here, and then a methyl down here. So it would be 2, 2, 3 trimethyl pentane. And we've established that this is the highest priority, going to the second and third, which would make it R223. Let's see if that's right. Okay. And R just means it's going clockwise, and S just means it's going counterclockwise. First we draw the hexane. We draw the 2, the methyl on the 2, methyl on the 3 position, methyl on the 5 position. Add the hydrogens, hit arrange, hit fit, hit roll. So again, I'm looking for the hydrogen that's different. And I see this one right here has 2, sorry, the carbon that's different. I see this one has 2 hydrogens. This one's got 2 methyls. This one has 2 methyls as well, so this is the one that's different. The hydrogen's in the back already, so we don't have to move it. The methyls where I like it. I'm going to ignore this one, and then I'm going to work with these 2 molecules. And they're both branched out, so this one I'm going to have to count. So we already had gotten 1 carbon out, so now we're going 1 more carbon. So these have 2 carbons right here, 1 carbon, 2 hydrogens. Immediately, when you have a greater number of carbon on one side, that's going to be the highest priority. So that would be, this is the highest, this is the second, this is the third, going around clockwise. Let's see if we're right. Okay, again, draw the hexane. Put a methyl on the 4th position, 1, 2, 3, 4. Ethyl on the 3 position. Add some hydrogens. Oh, I mirrored it. Add some hydrogens hit arrange, hit fit, hit roll. Okay, so this is one that got me earlier. I'm going to look for the chiral center. I look for the ones that have duplicates. This one has duplicates. And this is the other one that has a duplicate. It's got an ethyl right here. It's got an ethyl right here. So the chiral center would be this one. The hydrogen's pointing out, so I'm going to go ahead and roll that to the back. Right there. I got my methyl on the bottom where I like it. I'm going to ignore this one and start counting these. So I'm going to assume it's going to be this one, but let's count it just to make sure. 1 carbon out, just like we did here. 1 carbon out, 2 hydrogens. 2 carbons, 1 hydrogen. 2 carbons is greater than 1 carbon, so this is going to be greater. Second, least. So R3 ethyl, that should be right. Let's check. Okay. And as you go through this, you'll start seeing those trends where you can kind of guesstimate which one's going to be the highest priority, which is going to be the least. Of course, methyl's always the least. This one, like I said earlier, you can check for the 1 hydrogen. That's kind of a giveaway. And this one's easy. You can see all those hydrogens coupled up together on carbons. So this is the hydrogen. We're going to go ahead and turn that around. We're going to name it 1, 2, 3, 4, 5, 6, 7, 8. Octane. We've got 1 methyl right here. That's the only one I see. So on the 4th position for methyl octane. And now we do the prioritization. When it comes with the long branches, I've noticed that it's foolproof. The longest branch has the highest priority. So I'm going to go ahead and test that out without checking the bonds. And let's see if we're right. So that would be 1st, 2nd, 3rd. So around like this, counterclockwise, would be an S. And let's see. The branch ones, the ones with both branches on both sides are probably the easiest ones. Octane. Drawing the octane. Oops. One, two, three, 4. Methyl in the 4th position. Oops. Put it on the 5th. 1, 2, 3, 4. Okay, add our hydrogens, hit arrange, fit, roll. So automatically I'm already seeing this hydrogen in the back by itself. But we see all these hydrogens coupled, so this is the chiral center. I like my methyl on the bottom, so I'm going to turn it around. Like I said, you can leave it on the top. I got used to it being on the bottom. Okay, I'm gonna ignore this one. I see this is the longest branch, so we're just gonna go right into it. So left, right. We'll go clockwise, R. So let's see if we're right. All right. One last one. I'm looking for the chiral center, the one that's different. I see all these hydrogens coupled up to carbons. I see this one right here, which is going to be my chiral center. I arrange it so I can have my methyl on the bottom and my hydrogen in the back. I'm going to go ahead and fit it so I can see more. We've got our long branches again, so I'm just going to jump right into it. This is the highest priority, 2nd, 3rd. So 1, 2, 3, 4, 5, 6, 7, 8 is our longest branch. Octane. We have a methyl down here. That's the only position I see. 1, 2, 3. 3 methyl. We count this way because we want the lowest number. I'd rather have a 3 than 6. So 3 methyl, and then we've established this is going clockwise. So we're going to go ahead and put R dash. Let's see if we're right. All right,